Hello guys, good morning everyone. And this is a session about the 8-bit embedded platform. And this is the there is a series of lecture will be there on a 8-bit embedded platform. For choosing a and I have chosen a 8-bit embedded platform as a PIC microcontroller, the PIC 16F877 microcontroller. And the sources for the PPT has been taken from varieties of books and online resources, web resources, and also taken from the lecture series from NPTEL videos. The purpose of this PPT is made for classroom teaching. And in this session, we are going to see about the architecture of the PIC microcontroller. So before seeing the PIC microcontroller, let us see how the Microchip company, that is a manufacturer of PIC microcontroller, um, about the CEO of PIC microcontroller, the Steve Sankey. And the Steve Sankey, the chairman, the president, and CEO of Microchip Technology. The Sankey had moved from India to US to pursue the master degree at the University of Manchester. Manchester. After bachelor degree in engineering from Punjab Engineering College. Yes, he is an Indian and he is now the CEO of Microchip Technology. In 1993, Zankai became the president and CEO of Microchip after seeking advice from the venture capital firm on starting his own company. Since then, he has transformed the Microchip into a billion-dollar company specializing in microcontroller and analog semiconductors used in devices ranging from remote control to cars. He also has been involved in science and technology education program, and he is being known to frequent science fairs and questions kids about their project. And he is a person. So let us see about the introduction about the PIC microcontroller. The term PIC stands for Peripheral Interface Controller, and it is a brainchild of Microchip Technology USA, and they have coined this name to identify the single chip microcontroller. These 8-bit microcontrollers has become very important nowadays in industrial automation and embedded application and etc. The PICs are popular with both the industrial developer and the hobbyist alike due to their low cost, wide availability, large user base, extensive collection of application nodes, availability of low cost or free development tools, and serial programming and reprogramming with flash memory capability. Microchip PIC microcontroller are available in various types. When the PIC microcontroller was first available from General Instruments in early 1980s, the microcontroller had a simple processor executing the 12-bit wide instruction with the basic I/O functions. So these devices are known as the low-end architectures. They have a limited programming and are meant for the application requiring the simple interface functions and small program and data memories. Some of the low-end devices numbers are these are the series of family of the number 12C5XX, 16C5X, 16C505. The mid-range PIC microcontrollers are built by upgrading the low-end architecture with more number of variables and more number of registers and more data program memory. Some of the mid-range devices are 16C6X and 16C7X and 16F87X. The program memory type is indicated by the alphabet C, EPROM, F, flash memory, RC, master ROM. One of the mid-range versions of PIC microcontrollers is PIC 16C6X or 7X. The 7X family has an enhancement of the analog to digital converter capability. These microcontrollers are available with a range of capabilities, packaged with both dual inline package and surface mount packages. These are available in 28 pin. In the 6X 7X family of microcontrollers, the PIC16C62A and PIC16C74A are found with the suffix A. Some of the PIC do not contain this A. The presence of A indicates the brown reset features, which causes a reset of the PIC when the power supply voltage drops below 4 volt. Let us see the features of the PIC microcontroller. The speed, When it comes to the speed, when operates at the maximum clock, a PIC executes most of its instruction in zero point 0.2 microsecond or a 5 instructions per microsecond. The instruction set simplicity. The instruction set is so simple that it consists of just 35 instructions. Integration of operational features. The PIC supports the power on reset and brownout protection to ensure the chip operates only when the supply voltage is within the specification. The watchdog timer reset the PIC if the chip malfunctions or deviates from its normal operation at any time. The programmable timer options. The three timers can categorize the input, control output, and provides the internal timing for the program executions. The powerful output pin control. A single instruction can select and drive a single output pin, high or low, in its zero point 0.2 microsecond instruction execution time. The pin can drive a load of up to 25 microamperes. The I/O port expansions. With the help of the built-in serial variable interface, the number of I/O ports can be expanded. The EPROM dual inline package ROM options are available to expand. Interrupt control. Up to 12 independent interrupt sources can control when the CPU will deal with each sources. And this is a general architecture block diagram of a PIC microcontroller. In this, there is a this is a CPU, the central processing unit, which is operates based upon the 35 instructions. It's a very much simple and easy to execute. And let's start with the I/O ports. Each and every port, when we are having the port A, B, C, D, and E, total of 5 ports are available, each with different pins option is available. And then when saying about the memory options, and we are having the program memory of 8 kilobytes and EEPROM, that is electrically erasable programmable read-only memory of 256 bytes. And also we have the RAM, that is a random access memory of 368 bytes, and a special function register to do a special function for controlling operation of the PIC microcontroller. And there is a reset and power supply option. The power supply varies from 2 to 5.5 voltage of different PIC microcontroller, and a reset option is available. There is a various reset operation, and we will see in the further slides. And there is an interrupt and watchdog timer is available. The timers, we are having the timer 0, timer 1, and timer 2. There are three dedicated timer hardwares are available inside the PIC architecture. When saying about the serial communication, we are having the serial communication of USAT, Universal Synchronous Asynchronous Reception Transmission, and the serial peripheral interface and inter-integrated circuit for communicating with the external world, to transferring the data from and to between the CPU, this controller, and the other thing, and also the oscillators. We have the options of internal oscillator and also adding up to the external oscillator. The oscillator can operate around 0 to 20 MHz frequencies. And also we having the internal analog to digital converter, so that we can connect the external analog pin to the controller so that it can be converted into digital without any external hardwares. And also we have the reference voltage is available. Now to see the detailed architecture from the which is has been provided by the Microchip, and this is a detailed architecture view. In the detailed architecture, you will be having the port A with the 5 pins. So most of the pins have the alternate functions of analog communication connecting to the analog inputs. And the port B having the 8 pins, port C also having the 8 bits, and port D also having the 8 bits, and port E will have the 3 bits. And this is the reset circuitry, and you will have several reset options such as power up timer, oscillator startup timer, power on reset, watchdog timer, brownout reset, in circuit debugger, and low voltage programming. And this is the CPU of a controller. This is arithmetic and logical unit, and which will work on the basic of status register, that is a working register. We name it as a working register, W register. And also having the status register and a file selection register, and also RAM file registers, and we having the dedicated 8 level stack is available, and also program counter, And this is the flash memory, and this is the instruction register, which is directly connected to the address max. And this is the oscillator and the timing generations, which is given to this different controller controlling operations. And this is a master clear, and this is a supply source, and we are having the timer 0, timer 1, timer 2, and a 10-bit ADC. And also we have the parallel slave port, and there is a communication as a synchronous serial port USAT comparator, and there is a comparator is available to effective operation for the ADC, and also the voltage reference is available. Data EEPROM option and CCP. And we are going to see about the PIC 16F877A, which has a programmable flash memory of 8 kilobytes of flash memory and 365 bytes of data memory and 256 bytes of data EEPROM memory. And this is the pin diagram of the PIC microcontroller, and we are having the 40-pin dual inline package. 40-pin dual inline package, which has a 40 pins on the left side, that's starting on the pin A, pin 1, and we're having the 6 pins of port A and port B on the right side, and port C and D in the bottom left and right, and port E at the left hand side. That is from the E8 pin to 8, 9, 10. There are only three pins in the port E. The central processing unit. It is not different from the other variable CPU. On the PIC microcontroller, CPU consists of the ALU control unit, arithmetic logical unit, control unit, and a memory unit, and accumulator, etc. The arithmetic and logical unit is mainly used for arithmetical operation and to take the logical decisions. The memory is used for storing the instruction after processing. To control the internal and external variables, the control unit is used, which is connected to the CPU, and the accumulator is used for storing the results for the further process. Memory organization. The memory module in the PIC architecture consists of RAM, ROM, and stack. The RAM memory, that is a unstable memory which is used to store the data temporarily in its register. The RAM memory is classified into two banks, and each bank consists of so many registers. The RAM registers are again classified into two types, that is a special function register and the general purpose register. The general purpose register, so called as GPR, are used on if you want to multiply any two numbers, and the data will be stored in the general register, so it cannot it doesn't have any special function. It is used for only for storing the data values. The special function register, as the name indicates, it's a special function. It You cannot store any data values in the special function register, but you can able to, with the help of the special function register, you can able to control or any functions such as the timer operation, interrupt operation, and we can do some other things by using the special function registers. And also the read-only memory, which is a stable memory which is used to store the data permanently. In the PIC microcontroller architecture, the ROM stores the instruction of program according to the program the microcontroller acts. The ROM is also called as a program memory, wherein the users will write the program for microcontroller and save it permanently, and finally the program memory is executed by the CPU. The microcontroller performance depends on the instruction which is executed by the CPU. The electrically erasable programmable read-only memory. In the normal ROM, we can write the program for only once and we cannot use it again. The microcontroller for multiple times. But in EEPROM, we can program the ROM multiple times. The flash memory, we can make it can read, write, and erase the program thousands of times. Generally, PIC uses this type of ROM for programming. Stack. When the interrupt occurs, the PIC microcontroller has to execute the interrupt and the existing process address. Then that is being executed stored in the stack, and after completing the execution of the interrupt, the microcontroller calls the process with help of an address, which is stored in the stack and get executes the process. The stack is the place, so whenever there is an interrupt rises, the current execution address will be stored inside the stack, and after executing the interrupt, it will recall the address from the stack and start executing the already being executed program. I/O ports. There are PICs. The series of PIC 16 consists of 5 ports such as port A, B, C, D, and E. The port A is a 6-bit port and can be used for input and output based on the status of the TRISC register, that is a tri-state register, and additional functionality of ADC. The port B is a 8-bit port that can be used as a both input and output ports and for programming functionality. And port C is an 8-bit and input and output operation is decided by the status of the TRISC register and additional functionalities of communication operation. The port D is an 8-bit port and acts as a slave port for the connection to the microcontroller bus and additional functionality of parallel slave operations. The port E is a 3-bit port which serves the additional functionality of reading and writing from the external memory. And we'll be seeing it elaborately in the further lectures about the I/O ports. The bus. There are two different buses are available in PIC architecture, that is a data bus and the address bus. Which is data bus is used only for transfer or receive the data, and address bus is used to transfer the address internal and to the external using the serial communication protocols such as these GSM, GPS, Bluetooth, and IR, etc. An AD converter. The main intention of the analog to digital converter is to convert analog voltage to digital values. The AD module of the PIC microcontroller consists of 5 input for 28-pin devices and 8 input for 40-pin devices. The operation of the analog to digital converter is controlled by AD count 0 and AD count 1 special registers. The upper bit of converters are used in the register of address result H, and lower bit of converters are stored in the register address AD or the ASL. For this operation, it requires a 5 voltage as analog reference voltage. The analog signal is given to the analog converter and it is converted into the digital signal. The timer or counter. The PIC microcontroller has a 3 timer bar or counter, wherein one 8-bit timer and the remaining timers have the choice to select 8-bit or 16-bit mode. The timer are used for generating accuracy actions, for example, creating the specific time delay between two operations. Interrupts. The PIC microcontroller consists of 7 interrupt sources which are associated with the different variables like ADC, USAT, timer, and so on. Serial communication. The serial communication is a method of transferring the data one bit at a time sequentially over the communication protocol channel. USAT. The name USAT stands for the Universal Synchronous and Asynchronous Receiver and Transmitter, which is a serial communication for two protocols. It is used for transmitting and receiving the data bit by bit over a single wire with respect to clock pulses. The PIC microcontroller has two pins TXD and RXD. These pins are used for transmitting and receiving the data serially. SPI protocol and I2C protocol are used as a serial communication. The SPI protocol, the term SPI stands for Serial Variable Interface, and this protocol is used to send the data between the PIC microcontroller and other variables such as SD, sensors, and shift registers. The PIC microcontroller supports a 3-wire SPI communication between the two devices on a common clock source. The data rate of the SPI protocols is more than that of the USAT. The I2C protocol, the term I2C stands for Inter-Integrated Circuits, and it is a serial protocol which is used to connect the low-speed devices such as EEPROM microcontrollers and AD converters, etc. The PIC microcontroller supports a 2-wire interface, or I2C communication between the two devices can work as a master and slave device. And this is how the serial communication being executed between the PIC microcontroller and the personal computer by using the MAX232 IC, which is act as a level converters between the PIC microcontroller and the computer. At last, oscillators. The oscillators are used for the timing generation. The PIC microcontroller consists of the external oscillator like a RC oscillator or a crystal oscillator. Where the crystal oscillator is connected between the two oscillator pins, the values of the capacitor is connected to the every pin that decides the mode of operation of the oscillator. The modes are crystal mode and high speed mode and low power mode. In case of RC oscillator, the values of the resistors and capacitor determines the clock frequency, and the ranges of clock frequency is 30 kHz to 4 MHz. The CCP modules, the name CCP module stands for compare, capture and PWM, where it works in three modes such as compare, capture mode and PWM mode. The capture mode captures the time of arrival of a signal, or in other words, when the pin goes high, it captures the value of the timer 1. In compare mode, acts as the analog comparator. When the timer 1 value reaches a certain reference value, then it generates an output. The PWM modes provides a pulse width modulated output with a 10-bit resolution and programmable duty cycle. So generally we can say the capture mode counts on the external pulses. The compare mode produces an external pulses when the comparing operation is being done. The PWM produces an output pulse based on a duty cycle that of 10-bit resolution. So that's how we came to the we can able to understand the architecture of PIC microcontroller and various devices that being involved for the effective operation of PIC microcontroller. And thanks for following me. And this is the end of session 5 about the architecture. And in next session, we'll be seeing the detail about the memory organization of PIC microcontroller. And thank you.